Welcome to lesson 5 of the topic vectors. This is introduction to elementary physics. In this lesson we are going to be taking an example problem to illustrate how to determine the resultant of two vectors when they are inclined at an angle with respect to each other. So if you have not viewed the previous lessons, which are lessons 1 to 4, do well to locate them and view them. The link to the previous lessons is given in the description of this video. Also, do well to subscribe to this channel, hit the like button and turn on the notification bell so that you will always get alerted anytime new lessons are updated on this channel. Thank you very much. So let's go to the business of this lesson. The question we're about to solve reads thus: find the resultant of two vectors, 3 units and 4 units, acting at an angle of 45 degrees with respect to each other. Here we have two vectors that are acting at an angle with respect to each other. In the previous lessons, we've seen different cases and different approaches of how to determine the resultant of two vectors. Here now, in this case, the vectors are inclined at an angle with respect to each other. So I will also remind us and also recommend again that you try to locate the previous lessons from the link given in the description of this video so that you can get a broad understanding of what has been discussed so far. So in solving this question, the first thing we have to do is to bring out our parameter. We can assign P as 3 units and Q as 4 units. Now it doesn't really matter. We can decide to assign Q as 3 units and P as 4 units as long as we remain consistent throughout our solution. What that means is that since we have said our P here is 3 units and our Q is 4 units, we should stick to this throughout the solution. Okay, the angle of inclination is 45 degrees and then we are asked to find the resultant. Okay, so we can determine the resultant from what we've seen previously in the previous lessons, that r squared, from cosine formula, that r squared is equal to p squared plus q squared plus 2pq cos theta. When we substitute properly, we are going to be having the equation as 3 squared, r squared is equal to 3 squared plus 4 squared plus 2 times 3 times 4 cos 45. Solving that equation makes us to arrive at a solution such that r is 6.48 units. That is, the resultant is 6.48 units. So each time you have two vectors inclined at an angle with respect to each other, you can easily get the resultant by just applying your cosine, by just applying the cosine formula. Okay, but there is something I want to quickly mention that sometimes confuses students. That is, when do you use a plus or a minus in cosine rule or in cosine formula? In this formula here, we have it that r squared is equal to p squared plus q squared plus 2pq. Why not minus 2pq? So I want to clarify that because that point sometimes confuses students. Alright, so now let's look at another rendition of that cosine formula. We have it that r squared is equal to p squared plus q squared minus 2pq cos 180 minus theta. Now what do you observe here? The equation I have on the left is same thing as what I have on the right. The only difference now is that my sign has changed to minus. Therefore, the angle in the bracket is now 180 minus theta. Because mathematically, cos theta is same thing as minus cos 180 minus theta. You know, I mentioned in one of the previous lessons that in order to understand this, the solution to finding the resultant of vectors using parallelogram method, it was strongly recommended that you go and review sine and cosine rule, because these lessons do not capture the detailed explanation of sine and cosine rule. But just to note it here that once you have changed your sign to minus in the cosine formula, then the angle in the brackets will now be 180 minus theta. So if we continue our solution, we have it that r squared is equal to 25. That is 3 squared plus 4 squared now gives you 25. Minus 24 cos 180 minus 45. Like I said, whatever we have on the right, same thing we're having on the left. The difference now is that since we have changed our sign to minus, our angle in the bracket is now 180 minus 45. So when we simplify that, 180 minus 45 gives you 135. And then if we go ahead, we are going to have it as r squared is equal to 25 minus 24 into minus 0.7071. You can see that the cos of minus 135 now, I beg your pardon, is minus 0.7071. So by the time this minus multiplies this minus outside, you are going to have it to become a plus. So this still brings us to the same answer. The point here is, anytime you are rendering your cosine formula, your cosine rule, if you are going to be using a negative sign, okay, it means the angle in the bracket should be rendered as 180 minus theta. And if you want to stick to the positive sign, you just put your angle as theta. Okay, I hope that is clear. All right, so now we have been able to determine the magnitude of the resultant. Mind you, we mentioned in previous lessons that when you are dealing with vectors, your direction is also very important. So let's now see how we can determine the direction of the resultant. Finding the direction of the resultant from the question that we have, let's assume this is how our vectors are inclined with respect to each other. 3 units, 4 units at an angle of 45 degrees. So we are going to be using the parallelogram approach, wherein we develop this system into a parallelogram, okay, according to the parallelogram law of vectors. Here is going to be 4 units, and then the other side is going to be 3 units. Now, this approach has been extensively explained in lesson 4. Okay, so try to locate lesson 4. Okay, the link is in the description of this video. What we are just doing here now is I'm just trying to apply what I have explained in previous lessons to solve this particular problem. So according to parallelogram law of vectors, the resultant, after completing the system into a parallelogram, the resultant is going to be the diagonal that is drawn from the point of intersection in this manner. And then we have been able to calculate that resultant using cosine rule, which is 6.48 units. Then the direction of the resultant is given by this angle alpha, okay? And then this other angle here, from our knowledge of geometry, is going to be equal to 135 degrees, which is 180 minus 45. So like I mentioned, this has been extensively explained in lesson 4. Try to locate lesson 4 from the link in the video, in this particular video. Okay, for us to now be able to get the direction, let us extract out this triangle so that we'll be able to concentrate on the angle alpha there. Okay, I take it again. We just bring out this triangle. In solving the question, you may not need to necessarily draw this triangle differently. I'm only bringing out here so that you can be able to get a good graphic understanding of what is happening therein. So we also mentioned from lesson 4 that if we want to determine the direction of the resultant, we now apply sine rule. Applying sine rule here now will be giving us 6.48 over sine 135 is equal to 4 over sine alpha. When you cross multiply and do all the necessary mathematical steps, you are going to have it that sine alpha is equal to 4 sine 135 over 6.48, and then sine alpha is going to be equal to 0.4365, and then alpha is going to be equal to sine inverse, or the arc sine of 0.4365, which brings us to the point that alpha is equal to 25.89 degrees. So we've been able to get the direction of the resultant. I'm emphasizing again that you should try to locate lesson 4, where I took time to explain how to get the direction of the resultant from sine rule. So what we are doing here is just to apply that knowledge to solve this example problem. Okay, so I think this brings us to the end of lesson 5, this tutorial question. But I must also mention that your 3 units and 4 units can be placed anywhere, but just be sure that you are consistent all through. Assuming I placed my 4 unit in the horizontal direction, my value of alpha is going to be a little bit different, but that does not mean the solution is wrong. Okay, so this brings us to the end of this lesson, and remember to subscribe to this channel, turn on the notification bell so that you always get alerted anytime new lessons are updated. Thank you very much. See you in the next lesson.